Hey guys, today we will be talking about our problem number 2, that is lowest common ancestor. As you all know what is an ancestor is, it's a parents, I mean a complete hierarchy of your parents and parents, I mean kind of family you are having. So in trees also what we are going to find out LCA, that is the lowest common ancestor. So let's try to understand that first and then we will try to solve the problem. So for example, let's take an example of node 4 and node 5. This is my node 4 and this is my node 5. If I talk about who is the parent of node 4, that is 2, and who is the parent of node 5, that is also 2, then what will be the common ancestor of 4 and 5? That will be 2. So here if you will see, if I pass two nodes 4 and 5, then the ancestor will be 2. Let's take an other example where I will be passing two nodes, that is 2 and 6. So if I come here, what is the ancestor of 2? Ancestor of 2, let me write it here. Ancestor of 2 will be 1, right? And ancestor of 6 will be 3, 1. So what is the lowest common ancestor among 2? That is 1. Got it? 6 ancestor is 3. 6 ancestor is 3, right? 3's ancestor is 1. Then the common one between 2 and 6 is 1. This is the problem statement that we are having today. So how we are going to solve this? So let me just rough it and then we will try to see how we are going to solve this. So one thing that we need to keep in mind, that we have to solve this problem in time complexity of order of n. Let me write it here. Time complexity should be order of n, and space complexity should also be order of n max. Okay, so now let's try to understand that how we are going to solve this problem. Let me write it down once more. 1 2 3, 2's child is 4, 4 5, and here we are having 6. Okay, this is what we are having. So now what we are going to do, we are going to write a recursive function that will be calling itself. Okay, so if I will be passing the root node, it will try to go to the left of the root node, try to check if that is null, then return null. Otherwise try to go to the left of the root node, try to check if that is null, then return null. Otherwise try to go to the left of the root node, try to check if that is null, then return null. So in this case, once we will reach to the 4, for example, we are taking example of the first use case that we are having, LCA of 4 and 5. Okay, and the answer should be 2 in that case. So it will be returning, it will be getting null from the left hand side, it will also be getting null from the right hand side. Okay, so null from the left hand side, null from the right hand side. And then the next condition that we are going to write in our code, recursive code, that if we will find the node dot data, so for in this case it will be root dot data, come here, root dot data is equals to our n1 or n2. means we will find one of the node. In that case we will just return root. Okay, then we will be returning 4 in this case, so we will be getting 4 here. Similarly we will be doing the same thing for right side of the 2, that is 5. 5's left and right both are null. Okay, and when we will be returning back to 3, it will check that this root dot data is equals to n1 or n2. In this case it will be equal to n2, then it will be returning 5 here. One more condition that we are going to write in our recursive loop, that if left root dot left and root dot right, means from the left as well as from the right we are getting some values, then we have to return root in this case. So in this case, if I will say I will be returning in this case of 2, from the left I am getting 4, from the right I am getting 5, then I will be returning 2, right? So here 2 will be passed to 1. Now the same thing we are going to repeat for our right hand side. We will go to 3, from the 3 it will go to 6, it will try to check the left child and the right child, both are null. In this case it will try to see that 6 is not one of the node that we are looking for. It will return the null here, it will also return null to 3 will also return null to 1. We will get null from the right hand side. So from the one side we will be getting 2, from the other side we are getting null, then we will be returning 2, right, one of the node. So we will be getting, so that will be our LCA of 4 and 5, that will be equal to 2, right. That is one part of the problem. Let's quickly move ahead to the next part, that is in case what will happen in case of we will be having 2 and 6 as 2 nodes. So let's go to write that one again. 1 2 3, left hand side we will be having 4, right hand side 5, again left hand side we will be having 6 here, and we will be passing LCA of 2 comma 6. It should return 1. Let's try to understand that how it is going to happen. First we will come here, we will go to left of the node 2, it will find 2, but still it will it will get one of the node here, right. It will still go to 4, that is not equal to one of the node 2 or 6, then it will be returning null here. We will getting null from the left hand side. Similarly we will be getting null from the right hand side, and then we will be checking if this node root is equals to one of the node that we are looking for, then it will be returning root, right. Then we will be getting 2 here, correct. Here then we will go to the right hand side, go to 3 will go to 6 will check the left and right child, both are null. It will check the 6 is one of the node that we are looking for, it will return 6 here to 3 will also return 6 here. So to one node we will be getting 2 from the left hand side and 6 from the right hand side, so both are not null. In that case we will be passing back the root. Like if you remember, here we talked about that if root dot data is equals to root dot left and root dot right both are non-null, then we will be returning back the root, right. That's what here is happening. Okay, so this is how this particular thing will work, and the time complexity in this case will be order of n, and space complexity we are taking auxiliary space, so we are not going to consider that. Okay, and now let's try to understand it using the Python code. Okay, so this is the code that we are having, this is the code that we are having here. Here if you will see, two nodes will be passed, n1 and n2, and we are going to find out the ancestor of these two nodes. Like I said, I will just check if root is equals to none, I will return none. Otherwise I will keep on going to the left unless I found the none. Whatever I will be getting here, I will just put it under L underscore, then go to the right. Whatever I will be putting here, I will be putting in the R underscore. Okay, then this is the condition that I was talking about. If root data is equals to n1 or root data is equals to n2, one of the node that we are looking for, then I will be returning root. If L and R both are not null, right, one of the condition that we talked about, then we will be returning root in that case. Else if otherwise, if L underscore is not none, only one of them is not null, then we are just returning that one. Okay, same thing, if R underscore is not none, then we are just returning that one. Else there would be four conditions, right? Left, right, your left will be both are not null, one of them is null, and both are null, right? The last one is the both are null, then it will be returning null in that case. So this is how this entire function or class will work. It will give us the LCA or least common ancestor of our two nodes. I hope you like the video. Then please subscribe to the channel, and I will keep on posting some good solutions related to different data structure problems. Let's try to cover that one first, and if you are having any specific question, just write in the comment section. Thank you guys.